Thank you, Mr. Chairman. The topic of my paper is a dictation of human relaxation level based on deep learning. The outline of my talk as follows. The first is background and significance of the research. The second is the data analysis. The third part simply covers the ONN network structure. And the results analysis is given finally. Well, let's move on the first part of the topic, the motivation and the equivalent of the work. With the accelerate of the pace of life, more and more people are suffering from pressure from various aspects, which will produce a lot of mental illness patients. Therefore, it is necessary to assess the degree of physical and mental. Accurate assessment of the state of relaxation can help individuals timely know their vital signs and physiological stress, so as to take effective measures to get rid of the stress. And now, the popularity of wearable devices solves the hardware problem. As for the environmental construction, including hardware construction and the software debugging. Let's look at the picture first. We can know the web server and the coordination model are connected through the interface, and the coordinator and the intelligence watches are connected to the same network through Zigbee technology. As for the software debugging, according to the communication protocol of the coordinator, this article adopts Postman software or group decompression and relaxation training system for online debugging. Let's move to the data analysis, which consists of data processing and feature selection. First of all, look at the picture. The normal heart rate signal is shown in the picture below. The duration between two R waves is represented by the RR interval, and the normal RR interval date is between 600 milliseconds and 1200 milliseconds. The original pulse date were analyzed in time domain, frequency domain, and nonlinear domain to obtain the time domain, frequency domain, and nonlinear characteristics. In the end, SDNN, LF, and HF ratio and MNI were selected as the three-dimensional input of the neural network CNN. As for the feature selection, it contains SDNN, MNI, and HF and LF ratio. The mean NI is the average value of RR interval. The SDNN is the standard deviation of the interval between consecutive normal heartbeats and calculated as the following formula. As for the frequency filter, HLF and HF ratio expresses the balance between the sympathetic nervous system and the parasympathetic nervous system. The third part simply introduces the CN network. It contains input layer, conventional layer 1, masked polling, conventional layer 2, average polling, and the full connected layer. The CSV file composed of the selected filter is used as the initial input. The activation functions after the conversion layer are both relaxations. The activation section after the full link layer is the softmax section. According to the three classifications, the ONN network outputs the level of the relaxation index H. The larger the H, the more relaxed of the people are. In the last part, let's move at the results. It contains the horizontal comparative experiment and the longitudinal comparative experiment. As for the horizontal comparative experiment, all experiments are based on the 80% of the data as the training set and 20% of the data as the test set. We can see from two tables with the conventional layer is 2 and the iteration is 10. The result is best. We can see the accuracy is 0.811. As for the longitudinal comparative experiment, the research compared CNN RSTM and the SVM model and showed that the CNN network has the best experimental result. The evaluation indicators are accuracy, pressure, recall, F1 score, and loss rate. As for the CNN network, the scores are 0.811, 0.735, 0.91, 0.802, and 0.384 respectively. We can see from the table 2. Based on the experimental results, we can see that this research can monitor the degree of human relaxation with an accuracy rate of more than 18% and basically achieve the research purpose. Thank you for listening and ask the experts to criticize and correct.